Okay.
Hi, Professor. This is Naveen,
And this is Ron.
and in this video, we'll be demonstrating our business intelligence assignment 2. And in this video, we'll be discussing about the k-means clustering algorithm. To perform this algorithm, we'll need this libraries. First, we'll be using the pillow library, from which we'll be using the image class. Then we'll be needing the scikit-learn library, from which we'll be using the k-means clustering algorithm. So first I'll be using the pillow library image class from the pillow library to open the Canada.jpg image that you provided us with for this assignment. Then I use the matplotlib library to show how the image looked originally. Then I've used the numpy library to convert this image into an array. So okay, Ron, can you scroll?
Yeah, sorry.
Then so we can see the shape of this image. Its width is around 768 and its height is around 512, and it is of RBG channel. Then I'll be reshaping this array into a two-dimensional array. So once we reshape, we get this dimension. Then so this is our image array look like. So I'll be using this array to train my k-means clustering algorithm. So here's how we use the k-means clustering algorithm. So I define the number of clusters as 3, and then I set the random state as 32. Then I use my array image underscore np array to train this algorithm. Then I'll use this I use this trained model to predict the cluster with which the each pixels in this array belong to. So once we predict, we get the final output in the label variable. Now my colleague Ron will explain you about the rest of the problem.
Yeah, thanks, Naveen. So next we convert the vector of pixels to an image matrix. We'll set it back to the original dimensions of our image. Um, this is a small row of the image here, and this is the whole thing. And now all the pixels have been placed according to the algorithm. Next, we'll find the cluster centroids and the dominant colors. So first, we need the coordinates of the cluster centers, and we use centers. Right, so we get the centers from the k-means algorithm that we trained, and here they are, right over here. And then right, okay, so then we multiply each coordinate by 255 to get the RGB value, and here we have our three dominant colors. So we got a light brown, we got a cyan, and we get a kind of a dark brown black looking square. And with that we come to the end of our file. So thank you very much for listening and have a great day.
Hi, my name is Abdullah Muhammad. I'm Group 5. This is my part of the assignment 2, task 2, which is supervised learning. The first question is to load the data using pandas. I imported the required libraries, pandas, seaborn, matplotlib, scikit-learn. These matplotlib and seaborn, they are not required, but we might need them to visualize the data. We load the data by data equal panda.read underscore CV, then the path for the file. Here is the data frame. We just printed the head of the data frame to visualize or to see how the data looks like. The second part is to print out some sample rows and inspect that sample to identify the dependent and independent variables. We use data.describe to take a look on the statistics of the data frame. Then we took a look at data keys. Number 3, examine the values of each attribute and select set of attributes only that will affect and predict dependent variable. Here we will answer also the previous questions, which columns or which attributes are y values and which is x value. Again, description. The y values, we are trying to predict y value, which is the dependent variable. In this scenario is the diagnosis. The x values or are independent variables are who can affect the value of a diagnosis are almost 10 columns, and here they are listed below. Data.shape, and this is just a quick visualization just to take a quick look on the data set, how it looks like. Thank you.
Thank you, Abdallah. So question 4 of task 2 asks us to split the data between the dependent y and the independent s variables. So we've determined that diagnosis is the only dependent variable. This is going to be our y variable. So what we did is we first dropped it, since this is the column that we will be predicting, and then we assigned it to the dependent variable column. Question 5 asks us to determine the data types of each attribute and to encode the dependent variable using proper encoding scheme. So in order to do this, what we did is we used dat.info to learn more about the data types. We saw that there are 32 columns and only 2 are not of the float type. One is the ID, and this is not a dependent or independent variable. It's simply an identifier, kind of like our primary key, as well as the diagnosis, which is listed as an object. And what we do, everything else. So this is our dependent variable. It is categorical, binary. You can be benign or malignant. So what we did is we encoded it, gave it dummy variables 0 or 1. Here we encoded it with dummy variables 0 or 1, so it can be treated as a numerical value. All other data points are continuous numerical values. Question 6 asks us to split the data between the train and the test variables. So we use scikit-learn to do so. And we have about 398 of our 569 in our train set and 171 in our test set. That's or 70-30% split. We also included our random state. Thank you, and now to Tomasz.
Good afternoon. My name is Tomasz Szumski. I will continue our presentation. Thank you, Sophie. And I'll be talking about scaling, modeling, hyperparameter tuning. So first we import linear SVC and SVC from sklearn. We have our object linear SVC. So we assign to a classifier. We feed the model with X and Y data, and we have our prediction. The prediction is 0.85 accuracy, and this was done without any standardization. Now I will implement a standardization. So I will use a standard scaler. We transform X data, and now we feed it. We feed the system, and we perform linear SVC. As you see, after feeding the model with X train and Y train, we print our prediction, and it's 0.91, so way better than without normalization. Now our data is very small, so we are going to continue using SVC now. So we do the same for SVC. You see, our model works even better, is 0.93. Now I import classification, report, and confusion matrix from sklearn, print it out. Here are the results. So yeah, our accuracy is very nice. Our average is good. This is our prediction matrix. Now I will try to find I will try and test parameters. So we'll do the tuning using grid search SV. We are preparing sets of data for C as for gamma. Run the grid search, and as a result, we are getting the best parameters. And in our case, it's C equal 10 and gamma 0.1. Best score is 0.96. So yeah, we improved the score a little bit. Now, a few words about benefits and disadvantages of standardization normalization. So normalization is we use normalization when we put our data into ranges. Let's say from 0 to 1. Standardization is when we want to have a standard normal distribution, so mean 0 and standard deviation 1. So data is more centered. Some algorithms required, they assume that data is centered, or that around 0, or that they're looking for data in specific ranges. There are some disadvantages, and one of them would be that as a result of normalization, we can lose some data, mostly the outliers. Thank you.